Okay, my friends, last derivative last derivative I'll be taking for you. I'd like you to pause it, read this. Okay, great. So he has a note here, and I'm looking at this problem that we're doing as an example, and I'm showing there's not an example of the note. So I'm assuming that's going to pop up in the homework. So feel free to ask when you get stuck. When you notice that the second derivative is equal to 0, have me go over a problem like that in class. All right, this one's just a basic, okay? And just like the other problem, it was a quartic, only this time it's negative. So I know that flips it around. So instead of the picture that I thought I had before, I likely have something where there's a max here, a min here, and a max here. Now I want to caution you that you have to test, because sometimes you end up with a function it has a point of inflection in it, but it doesn't really actually have a max. Okay, so that it looks sort of like a lump around here, and that's why you have to test and make sure that it's not actually strictly increasing. Okay, because it might be concave down from here to here, and then it's concave up from here to here, but there's no actual local max. Okay, now this one there is, we'll see it, but I just wanted to caution you about the shapes of graphs sometimes being lumpy in such a way as it doesn't actually make a max. Okay, so taking the derivative f prime of x, I get negative 12 x cubed plus 12x. Taking the second derivative, f double prime of x. Oh, well, hold on. He says use the second derivative test, which you just read about. And so I do need a first derivative, and I do need to factor it and find out, what my critical numbers are. So I'm going to factor out that negative 12x, and I'm going to get x squared minus 1, which is nice because I know how to factor that. This is negative 12x times x plus 1 times x minus 1. And that leaves me, when I set this equal to 0, with my critical numbers of, don't forget this, kids forget this all the time, x equals 0, okay? It is one of my critical numbers. If I throw in a 0 and a 0, I should find that there is some kind of behavior happening there. Okay, so that's good. And then the other numbers that I have are positive 1 and negative 1. All right, so those are my critical numbers. Now, the second derivative test says you don't have to use the first derivative number line or the first derivative test to check to see, slopes are positive and then slopes are negative. You can actually use the second derivative, which, when it's easy enough to calculate, is a nice, pleasant thing to do. F double prime of x equals, ready, I'm going to have a negative, and it's going to be 36x squared, and this is plus 12. So that's an easy derivative to take. I can start checking what's happening with my critical numbers and find out, am I getting positives or am I getting negatives? And that'll tell me whether or not I have a max or a min. That's my justification for maxes and mins. And especially when I have an intuition about what the graph looks like, that helps me a lot, okay? So I want to double check this derivative, this double derivative. I want to check it at negative 1, I want to check it at 0, and I want to check it at positive 1. And again, these numbers are small and they're easy, and so this is why I would use this tactic here. So negative 1, I get a positive 1, negative 36 plus 12 is going to be a negative number. Okay, so that means that my graph is concave down, and I can with confidence say that I have a local max at x equals negative 1. Okay, here I'm going to plug in a 0, and then I get positive 12. So that's positive, which means that it's concave up, and I can say with confidence that I have a local min at x equals 0. And the last one, plug in a negative 1, plug in a positive 1. I'm going to get the same thing either way. This is going to end up being a negative number, and that means that it is an absolute max. A local max at x equals 1. And again, check this graph, okay? Actually check it on Desmos, and you'll see that it has a shape somewhat like that. you're ready to do homework.